Okay, see, basically first, okay, that's very easy. The second video was about the transistor, where you started off the technology, how it scaled, the journey right from the very first transistors to the very latest new transistors that are being discussed in the industry. That was showcased. That was the first video. Second video told you about the first video told you about the power via, which is basically getting all the power connections on the other side of the die, such that from the back side, where the back side has all the power connections and the front side has all the signal connections. So this was the connectivity. And then the later one you got was on the packaging technology, where you spoke about the various packaging methodologies that you follow on the EMIB way and then do. So this is the quick overview of the three videos that we went across. Do you need more detail?
No, sir, thank you.
So let me tell you why do we need a tape out and what happens by giving you a bigger, more top level understanding of what constitutes the semiconductor ecosystem. Semiconductor ecosystem really needs 5 steps in its process. First thing is design activity, then the wafer fabrication, packaging, testing, sales and distribution. So these are broadly the 5 activities which happen from where you undertake the activity and ensure the silicon products, packaged products are available in the customer's hand. To do that, we have a small grid where we understand what is the ecosystem, and in the current perspective where we are hearing the Indian Semiconductor Mission or the government of India giving a lot of emphasis on various fabs. Let me educate a few people on a certain intricacies of that. So one is called an integrated device manufacturer called IDM. This player in the industry does all the 5 steps that are needed. Currently, the most common IDMs are Intel and Samsung. Okay, there have been IDMs earlier. For example, TI used to have an IDM earlier. NXP used to be an IDM. Micron used to be an IDM. So there are many IDMs, but they have not scaled down to the latest technologies. They have limited or restricted themselves due to their business needs for their analog processes at higher technology nodes. Next comes the fabless companies. Fabless companies basically do only the design of the work, get and do the sales and distribution of the work. Some of the common design activities would fabless companies would be your Apple, Qualcomm, and Nvidia. So what they do is they do a lot of these things. They also might do some amount of testing, but they do not do bulk testing there. They get the tests done separately. They only deal with the IP sales or the IP distribution later. So they have only two components, design and sales. Third is an IP company. IP company is the one which does sub-modules which are very specific but sell in volume. That makes good sense that they only do the design activity and they build the IP. They would probably test it once as a prototype. Once the prototype is done and it is silicon proven, then they use that to sell it to the various fabless or IDM companies or any other product based companies who utilizes these IPs. They only do the design portion. Then comes the design house. Design house could be people who do both some amount of the activity in the design side and some amount of activity on the mask generation and the wafer fabrication side, but they do not do the rest of it. Very, very few are come into this nature. And then comes the pure play foundry. The pure play foundry is what they do is they do the wafer fabrication portion and they work with other partners in the ecosystem to ensure that they get the packaging and the testing also done. Okay. Now, if you look at assembly and testing, assembly and testing is only they do the packaging. That means they from the foundry, they get the dice or the wafer. Then that comes into their office. They do the dicing, which is basically cutting the dice. And after cutting the dice, they do the packaging. And after the packaging, they bring out and do the testing. Okay. Now, Why is this foundry assembly and testing are all needed? The government of India has started certain initiatives with Assam and Gujarat in nature. And you see them, they are basically doing a fab and they are doing assembly and testing. They are not doing an IDM or they are not doing a fabless, nor they are doing an IP company. So a foundry or a fabrication activity is happening in one plant, probably in Gujarat. Then there is something called an OSAT, outsource assembly and testing facility, that is happening in Assam. That is also happening in some parts of Gujarat also. So if you see, all of these are not in one place. They will all be in different places with different activity, and this forms the semiconductor ecosystem. Now, if you look at what is an IDM, by the logic understanding that we do here, mathematics, a fabless company plus a foundry would end up being what is an IDM. So they will have a bigger scale, bigger scope, and other activity. Now, coming to the title of this talk, right? We said what is a tape out. Now, there are the places where tape in is also being used. So, what is the difference? Difference lies in a very simple one. So, when you have a fabless company who is doing all the design, and then you have a foundry where who's doing the manufacturing. So, when a design goes from a fabless to a foundry, right? That is where it happens. Design goes from a fabless to a foundry. Now, the difference comes here. If there is a company A where it contains both the fab, the design house, and the foundry put together, that place, which is typically called an integrated device manufacturing company or an IDM, and another case where you have a company B, which is a fabless company, which does the design and sends it to a company C, which is a pure play foundry. For example, TSMC is a pure play foundry, and company is NVIDIA or Qualcomm, for example. So if you have company A, could be your Intel or a Samsung. So these are the examples I'm giving you for each of these companies. So when you probably give your design from your design house into your company, which has a foundry, it's called a tape in. Whereas when you have a fabless company, the design goes outside your company and into a pure play foundry. It's called a tape out. Now, why do we call it a tape or the word tape in? Tape used to be an earlier a magnetic disc or a magnetic tape on which this used to run. So for the current generation of people who do not
हाँ
understand tape,
जावेद भाई नमस्ते कैसा है
I'm sorry, who's this? Is there a question? Okay. So when you have the tape used to be a magnetic tape, and those people of generation who have not seen a tape recorder through which cassettes used to be placed, imagines for where these cassettes used to be played using music for music in our time, say about 15-20 years back. Tapes used to be used to take these designs, record their data onto these magnetic tapes, and then send it outwards to the foundry. And the foundry would take these tapes, tape it inside into their device, into their fab and their workshop, get all the designs and done. So that is why the term tape is still kept in tape. Right now, what you would do in your company is you would probably do a GDS2 stream out, and that stream out would become go to a hard disk. You would secure it, and then transfer the data from your design portal to the pure play foundry's input portal by a secured communication. You would not have tape in, you just have a digital transfer of data. But tape in used to be there to acknowledge the magnetic tape that used to be present there. So these are the two important things. And I will just give a 2-minute introduction on what are the electronic design automation and the historic perspective and its need right now, just to show how important it is. There has been a time where drawings used to be done on large papers. We used to have jobs called draftsmen who used to draw these on the physical paper, and then that used to go into the design house and they would shrink the design optically. Beyond and this time you were working at hundreds or probably thousands of transistors. But as the design started to scale, we had to use the computer and the various softwares that came into the picture along with the automation to ensure the scalability of the designs took place, where we went from tens of thousands of designs to a million, and currently we are working in the age where we are doing billions of transistors, and in some cases a couple of billion transistors in a single die or a processor die or a chip. So this is the kind of design complexity that is there. Without the use of tools, it is very, very difficult to do it. And these tools that we use right now are called your EDA tools or electronic design automation tools that are going through. So this has been the core of the growth of electronic design automation in the semiconductor industry. So now before I go to the next set of slides, I'll probably answer a few questions before I go through.
I am hearing about VLSI since 15 years.
Right.
So has the industry not updated to ULSI?
Come again.
From VLSI to ULSI, is this shift expected any in near future?
Okay. So VLSI industry we have been speaking about is a name, but if you look at ULSI, uh, I would give you a time perspective in such a way. VLSI, we were there probably in the 90s. ULSI would be late 90s and early 2000s. So it's already been 2 decades that we have gone way past ULSI in the naming terms, but we have stuck with VLSI because it's just an industry name that we continue to use it. So we are way beyond ULSI also, probably at least 2 decades further. Right? I hope that is fine. Okay, I have a question saying in what ways currently AI is being used with EDA. So there are multiple ways. For example, each of the ADI vendors, EDA vendors that I have listed here, and if you look at the top three predominantly in our market, which would be Synopsys, Cadence, and Mentor Graphics, they have brought in various AI methodologies to bring in. First thing they do is how can they remove the regular or the mundane activities that a designer had to do? Can we automate that using an AI tool? Second, there are many verification checks that needs to be done on the engineer side before they sign off. Can they also automate that using an AI such that some of the intelligent activities that human design engineers need to use, can we bring in them and use that? So in the last couple of years, if you have attended some of the trade shows or some of the conferences held by each of these companies, you would have seen the latest innovations that they have brought in, and to see how they can reduce the time to market and enhance the productivity. EDA is always used to enhance productivity and reduce the time to market. This the way you can do a simulation methodology, or how you can do a testing methodology, how you can do a verification methodology. Most of the time it is to reduce the total time taken, as well as reducing the design cycle time, as well as ensuring uh, most of the mundane regular activity which can happen is tool driven rather than engineer driven, so that the engineer can spend on more critical activities in the design. So this is how AI is coming into the picture in 2024, and we will see a lot more AI in the very near future, in the couple of years, where you would see predominant domination of AI into the verification and simulation methodology, and that will give a lot of space for the human engineers to uh, find new ways, new methods, and intelligent solutions of what they can do. Okay, so Anand says how the semiconductor industry is related to NVIDIA. NVIDIA is a semiconductor company, and it is also one of the companies which builds a lot of chips. And these chips are used in various AI modules, hardware side, where they are running various compute nodes in the GPUs or graphic processor units or various AI processors. So NVIDIA is definitely a part of the semiconductor industry. Mr. Pathan asked, in which part of VLSI design flow AI can't do the automation? It is probably the circuit design, which is there, probably in the analog and RF circuit design, where AI is yet to get its kind of dominance that is getting in digital and the Verilog flows. That is because there is a lot of intuition and a lot of design knowledge goes into it. You would see that also coming, but not so far. Revant Reddy, it is very funny
What?
that you use Telugu. రైతు బండి ఎవరికి కావాలో వాళ్ళు అప్లికేషన్ పెట్టుకోండి. So see, either keep the question relevant to
Sorry,
it,
my
or
question.
please do not pass comments unless you have a very specific question on that. So if Mr. Revant Reddy is speaking, please go ahead. If not, we can go to the next question.
Yeah. My question is, what is circuit design in VLSI? How is it different from normal PCB design?
Okay. PCB is called, that is used to do the external connectivity of the design. Circuit design happens on the ASIC or on the silicon. PCB typically happens on the FR4 boards, where the design within a chip through a package is brought out through the copper conductors onto the other connectivity and work with others. So PCB is the board that you physically see, and circuit